Hello friends, I welcome you all again in this initiative by TEQIP Faculties in order to provide free GATE classes to each and every student in India. In this lecture series, we are studying transportation engineering, and this is module 3 in which we are looking into the pavement materials. We studied soil in last topic, and in today's lecture, we are going to start discussion about aggregates. You have seen the use of aggregates everywhere in civil construction, from buildings, bridges, road pavement, everywhere. So let us dig deep into what an aggregate is and what are the properties of aggregate which we require in pavements. As we know, aggregate is a combination of distinct particles gathered into an aggregate mass. In pavement, aggregate is used in base, sub-base course, shoulders, as well as in pavement surface. In bituminous mix, which is your flexible pavement surface, the aggregate consists of around 92 to 96% of mass. And in cement concrete, in which a slab is provided as your surface course, aggregate consists of around 80 to 85% of the mass. These aggregates may be obtained from a natural source or from an artificial source. From a natural source, this is obtained from rock formation by quarrying. These are excavated and crushed to obtain different size of aggregates. For artificial aggregates, the byproduct of manufacturing industries like slag from metallurgical industries, broken bricks, oven burned bricks are used as aggregates. For natural aggregates, the classification is based on their parent rock. As we know that rocks are divided into three categories. One is igneous rock, sedimentary rock, and metamorphic rock. Igneous rock are formed by molten lava or molten magma. This molten magma cools down at different level of Earth's surface, and after cooling they turns into solid hard rocks. Igneous rocks can be further classified into volcanic, plutonic, and hyperbasal rock. A volcanic rock forms when the magma cools down at the Earth's surface. A plutonic rock forms when the magma cools down at a greater depth in the Earth's surface. And a hyperbasal rock cooling of magma at comparatively shallow depth from the Earth's surface. For example, if the magma cools down below or near around 2 kilometers from the Earth's surface, then the rock formation will be known as hyperbasal. The best example of igneous rocks are granite and basalt. Talking about sedimentary rock, sedimentary rocks are formed by layers of sedimentary depositions on the bottom of oceans, lakes, and due to heat and pressure, they transform into rocks. These rocks are again classified based on the mineral or the predominant mineral present in them, like calcareous rock, the rock which has predominantly calcium. Example is limestone. Then siliceous rock, in which silica is present. Example is sandstone. And argillaceous rock. The composition of argillaceous rock is similar to clay. The example is shell. Then we have metamorphic rocks. Metamorphic rocks, the rocks which are formed after heat and pressure application to igneous and sedimentary rocks. These metamorphic rocks are formed when igneous or sedimentary rocks are subjected to heat and pressure to change their mineral structure. The rocks like quartzite, marble, and shell forms from igneous or sedimentary parent rock after the application of heat and pressure for a long time. Like limestone changes into marble. Now these aggregates can also be classified on the basis of their composition. They can be classified as acidic aggregates and basic aggregates. Acidic aggregates have more than 66% of silica in it, whereas the basic aggregates has less than 55% of silica in it. The specific gravity of an acidic aggregate is less than 2.75, and the specific gravity of basic aggregate is more than 2.75. So if we compare these two types of aggregate, acidic aggregates are comparatively less denser and basic aggregates are comparatively more denser or denser. Acidic aggregates are light in color, whereas the basic aggregates are dark in color. Talking about the desirable properties which we want to see in aggregates, aggregates should be free from clay and organic mineral. Why? Because with moisture, the clay and organic mineral tend to change their dimension. The swelling occurs, and this kind of change in dimension is not desirable in your pavement aggregates. Then the aggregate should be angular, because the angular aggregates provide interlocking, which is desirable property to give strength. But at the same time, they should not be excessively flaky. What is flaky? Any aggregate having one of the dimension very less as compared to the other two. If one dimension is very less, this will sustain very less weight. Then the aggregate should be strong enough to resist crushing during mixing, laying, compaction, consolidation, and in-service wear and tear. There should be resistance to abrasion and polishing when exposed to traffic. What is abrasion? When a particle is applied some surface rubbing with another material. Abrasion occurs when two different material rub each other, and if there is any surface change, this means the material is soft. If surface is good enough after the wear and tear, we say this material is hard. So we want the material to be hard. There should not be wear and tear while in service. The material should be, or the aggregate should be, non-absorptive, means there should not be any tendency of absorption of water, because if they absorb water during low temperature durations, the water will freeze, the volume will increase, and this will cause disintegration of the rocks or the aggregates. Then if they absorb water, they will have less affinity for the bitumen or to the binder to bind properly. So the binder to bind properly, there should be less water or no water present on the aggregates. Then we have, they should have good affinity to bitumen in case of bitumen pavement. Means they should allow bitumen to bind its surface properly. There should be less reactive silica, because if silica is there, it will react with alkalis and form a explosive reaction. If silica and alkali reacts and explosive reaction occurs, it will lead to disintegration of your formation, either pavement in bitumen or your pavement in concrete, cement concrete. So these are the desirable properties desired from your aggregates. So let us see what are the tests which we are going to conduct to see the desirability or the usability of these aggregates. First test is your crushing test. Crushing test is done in order to check the strength of aggregates. Strength is checked with gradually applied load. Then we will check the abrasion. Abrasion is the definition of hardness. If the material is hard enough, there will not be any wear and tear on the surface of this aggregate. But if it is not hard, with the wear and tear, you will see the surface is disintegrating. So the abrasion test is done to check the hardness. Then we will check the impact test. Impact is the sudden load. If sudden load is applied on a aggregate, how this behaves, this will tell us about the toughness of the material. So strength, hardness and toughness are checked by crushing test, abrasion test and impact test. Then we have soundness test. Soundness means how does aggregate behave in different weather. At different weathering conditions, if aggregate behave properly, this is durable. If it is not behave as desirable, then it is non-durable. So we check the durability of the soundness or of the aggregate through soundness test. Then we check the shape of the aggregate. Aggregate should not be flaky as discussed, and also it should not be elongated. Elongated means if one of the dimension is comparatively larger than other two dimension, excessively larger than other two dimension, then the aggregate is known as elongated. Elongated aggregate is not very strong if we compare it in the cement mix or concrete mix. Then we have specific gravity and water absorption test. Bitumen adhesion or stripping value test is also important for bituminous pavement. So these are the following tests which we are going to study today. So let us start with the crushing test. Let us start with the aggregate size gradation first. What is gradation? Gradation means in a mix of concrete, different or mix of aggregates, different size of aggregate should be provided, because these different size of aggregates will help to fill the voids present between aggregates. And if these voids are filled, the contact area between the aggregates will increase. If the contact area between the aggregate increases, the friction between aggregate will increase. The interlocking between aggregate will increase. And the cohesion between the aggregate will increase. And this in turn will increase the strength of your concrete mass. So we want the aggregate gradation should be denser, with all the or most of the voids filled with smaller aggregates. The maximum size in a gradation is defined by the smallest sieve size through which 100% aggregate passes. Let us say we have sieve size 20 mm. This sieve is placed over a sieve of 12.5 mm, and this sieve is placed over another sieve of 10 mm. Aggregates are poured on 20 mm sieve, sieving is done. Then if we check, all the aggregates have passed through your 20 mm sieve. So can we say that the maximum size of aggregate present in that gradation is 20 mm? No, because we have to check the sieves below it. Then we checked the sieve which is of 12.5 mm opening size. We saw there is no aggregate present on this sieve either. So 20 mm size is not the maximum size because no aggregate is present between 20 mm and 12.5 mm. Then we checked the sieve size 10 mm. There we found some of the aggregates. This means there are some aggregates which are present between the size 12 mm to 10 mm. Means 12.5 mm is the maximum size of aggregate present in this gradation. If I say I have some aggregates of 12 to 12.5 mm, means some of the aggregates may be of size 12.5 mm. So this is my maximum size. I hope you have understood the maximum size. Another definition which is usually seen is nominal size. Nominal size means the maximum sieve size that retains not more than 10% aggregate by weight. What is maximum sieve size? If we have this arrangement, again let us see 20 mm, 12.5 mm and 10 mm. From this sieving, we found that around 8 to 9% of the aggregates stays over 12.5 mm sieve and 5 to 6% aggregate stays over 10 mm sieve. So for this gradation, this 12 mm sieve size is your nominal size, because if we compare these two sizes, 12 mm is the maximum sieve size that retains not more than 10% of the aggregates by weight. So this is nominal size. We know that the pavement thickness or thickness of any layer depends on the size of the aggregate, and it is around 2 to 3 times the maximum size of the aggregate, which means in a layer, if maximum aggregate size is this, there will be only 2 to 3 aggregates present if they are placed in the layer consecutively. The same thing is seen in the apparatus design. Whenever we design apparatus, the apparatus is designed such a way that at least 5 aggregates of the maximum size can be accommodated in this apparatus or a mold of apparatus. So the minimum thickness of layer is 2 to 3 times of the size of maximum aggregate. The gradation of aggregate is done on the basis of Fuller-Thomson equation, and it is also known as 0.5 power law. This is important to remember. What is P? P is the percentage of aggregate by weight passing the sieve size D. Means if I want to select 10% or 10 mm size aggregate, maximum sieve size is 12.5. So the maximum percentage of aggregate which I can use is 10 by 12.5 raised to power 0.5 or under root of 10 by 12.5. This will give us the percentage of aggregate passing through 10% sieve. This is how we decide the gradation. Now let's discuss the crushing test. Crushing test is a test in which strength of the aggregates is tested. Strength of the aggregate is tested with gradually applied load. The load is applied gradually on the aggregates and the behavior of aggregate is observed. A mold of size 11.5 centimeter dia and 18 centimeter height is taken. The aggregate which are used for testing is passed through 12.5 mm and retained on 10 mm sieve. These aggregates are placed into this mold in 3 layers with 25 blows each, so that each layer compacts in kind of dense arrangement. The weight of this sample is calculated as W1. Now, a load with a rate of 4 ton per minute is applied to a maximum of 14 ton. Now, after this load, the sample is sieved through 2.36 mm sieve. Here you can see the size of aggregate is not less than 10 mm. But what we are doing, we are sieving the aggregates from 2.36 mm sieve. This means the aggregate must have crushed. But what we are checking, if the size has reduced less than 2.36 mm. Now the aggregate passing through this 2.36 mm sieve is weighted and a ratio of the W2 value and W1 value is taken and converted into percentage. This percentage is known as aggregate crushing value. For surface course, aggregate crushing value should be less than 30%, means not more than 30% of the aggregate should pass through 2.36 mm sieve after crushing. And for base course, this value should be less than 45%. Let's see abrasion test. Abrasion means surface wear and tear. We are checking hardness in this test. There are 3 apparatus which are used, or 3 test arrangements which are used to calculate abrasion. First is Los Angeles abrasion test. Another one is Devil's abrasion test and Dory's abrasion test. This is the setup of your Los Angeles abrasion test. These pictures are taken from Google Images. You can also find these images there and see yourself how these equipments look like. This is a roller and this is the cap of this roller. This cap is removed and aggregates of around 5 to 10 kg, depending on various gradation, are poured into it. Then these steel balls known as charge of around 300 to 400 grams are poured along with the aggregates into this roller. Then this cap is clamped with the help of bolt and revolutions are allowed. Around 500 to 1000 revolutions at a speed of 30 to 33 rpm is provided, and then the sample which is left is taken out. Now this sample is passed through a sieve of 1.7 mm. So this is the test in which Los Angeles abrasion apparatus is used. The drum size which we have seen is around 700 mm to 520 mm. The diameter is 700 mm and the length of drum is 520 mm. A spherical ball, which we have seen here, which is known as charge, this is made up of cast iron, has a diameter of around 5 centimeter or 48 mm, weight of around 340 grams to 445 grams, is placed with the aggregates into the drum. Then revolution of 500 at 33 rpm is applied. The sample is then sieved with a 1.7 mm sieve, and Los Angeles abrasion value is calculated by the same weight of material passing through 1.7 mm sieve to the initial weight into 100. So this is Los Angeles abrasion value. This Los Angeles abrasion value should not be more than 40% for water-bound macadam and should not be more than 35% for bituminous cores, as bituminous cores is a surface layer. This surface layer should not have more wear and tear with the moving vehicles. Here, the coefficient of hardness is also calculated. The coefficient of hardness is calculated by 20 minus loss of weight in grams. Loss of weight is initial weight minus your, or you can take W2 as your loss of weight, divided by 3. So this value is also calculated and is quoted as coefficient of hardness. So these important parameters should be remembered. These can be directly asked into the examination. Then we have impact test, the test which evaluates the resistance of sudden loading on the aggregate or toughness of the aggregate. The aggregate tested are aggregates which are retained on 10 mm sieve and passed from 12.5 mm sieve. These are filled in a mold of diameter 10.2 mm, which has depth of 5 centimeter. Then the impact is provided with a hammer of weight 13.5 to 14 kg. The fall of this hammer is 38 centimeter and 15 blows are applied using this hammer. Then the sample which is left after impact is passed through 2.36 mm sieve. In same way which we have earlier seen, the impact value is calculated, which is the percent of aggregate passing the sieve size of 2.36 mm to the total weight of aggregate of sample. The impact value should be less than 30% for your surface cores and should be less than 40% for your water-bound macadam. So this is impact test. These values are important to remember. Next test is soundness test. Soundness means how the material behave in weathering condition. This soundness test is actually a accelerated weathering test, in which different cycle of weathering, wetting or drying is provided, and then the aggregate is checked for its behavior after these cycles of wetting and drying. The solution of either sodium sulfate or magnesium sulfate is used. The sample is submerged for 16 to 18 hours in this sodium sulfate or magnesium sulfate, and after 16 to 18 hours the sample is taken out and dried at a temperature of 105 to 1010 degrees Celsius. This cycle is repeated for 5 times, and after 5 times, if loss in weight is more than 12% for sodium sulfate and 18% for magnesium sulfate, then the material is not considered to be durable. That's why we say that soundness test is done for durability of aggregates. We know that porous aggregates are subjected to freezing and thawing. What is freezing and thawing? Freezing means whenever the cold season arrives, there is liquid inside the aggregates, in the pores of the aggregates, which freezes. And because of this freezing or the inter void liquid which freezes, because of this freezing, the size of aggregate increases, or the size of the layer increases, or the swelling takes place. After the thawing, because of that false swelling, after thawing, that place subsides because of the melting of that ice. So this causes premature disintegration of your pavement. So this is undesirable. So to check this, we do soundness test. Then we have shape test. As we know, the flakiness or elongation or elongated aggregates are not the desirable property of aggregate. If the aggregate size is comparatively more or comparatively less in one of the dimension, then it is known as flaky. And if aggregate size is comparatively more in one of the dimension, it is known as elongated. To check the flakiness index, let us take an example. We want to check the flakiness index of the aggregates which are passing through 12.5 mm sieve and which are retained at 10 mm sieve. So we want to check the flakiness and elongation index of these particles. So these particles are taken by weight. This test is done for aggregate size more than 6.3 mm, more than 6.3 mm. So this aggregate size is taken. Now this equipment is for testing flakiness index or flakiness of particles, and this equipment is for checking elongated particles. Now the mean of this value is taken. Mean is 10 plus 12.5 by 2, this is 11.25, and is multiplied by 0.6. So whatever value we have here, let us calculate it. 6.75 mm. What we want for these aggregates, none of the dimension should be less than this dimension. None of the dimension should be less than 6.75 mm. These slots which are visible here are of this value or this dimension. For different sieve sizes, these have size of 0.6 mean times mean of, this is the mean. So we try to pass each and every aggregate from this slot of their desirable size. And if any particle from any dimension passes through this slot, we say this particle or this aggregate is flaky aggregate, and that aggregate is discarded. So we want least or no particle to pass through this 0.6 mean dimension size. Now we have elongated particles. Those particles which passes flakiness index test, or which are good particles, which are not flaky particles, they are tested for elongation index. Let us say we took 100 particles or 100 grams of particles or aggregates, out of which 20 grams of aggregate are flaky. So we are left with 80 particles or 80 gram of aggregates. So these 80 gram of aggregate will be tested for elongation index. So now we take these 80 grams to elongation index test, and for elongation index test 1.8 time of their mean size, means if the mean size is 11.25, we will multiply it by 1.8, and this x size, let us calculate this also. Let us say it is 20.25 mm. So for these particles, we don't want any of the dimension to be more than 20.5 mm. We don't want any of the dimension to be more than 20.5 mm. So these slots are provided. The length of this slot is equals to 1.8 time of your mean size. Different mean sizes for different sieve arrangement. So let us say for 12.5 mm to 10 mm, this slot is given here. So we try to block this slot size with all the dimension of the aggregate. If none of the dimension blocks or does not pass through this from any dimension, if aggregate does not pass through this slot, we say the aggregate is elongated. So this is how we check flakiness index and elongation index. And the total value, if we say 20% of particles are elongated or 20 gram of aggregates are elongated out of this 80 grams. So the final value or the final aggregate which are good out of our sample is 60 grams. So we say that 40% of the aggregate are elongated or flaky. And we say that for better pavement condition, the value should be less than 40%. So for pavement aggregates, the flakiness and elongation index combined value should be less than 40%. So this is your shape test. Then it is angularity number. What is angularity number? If a particle is round, it will not give you proper interlocking. We want aggregates to be bit angular but not flaky. So we check the aggregates for their surface texture or angularity. Angularity number is the value of aggregate angularity. If aggregate number is more or higher, it gives you higher angularity. Aggregate number is calculated by subtracting solid volume from 67%. Solid volume by 67%. It is considered or it is calculated that for perfectly round aggregate, the packing efficiency is 67%. Means in a volume, if totally round aggregates are packed, the solid volume in this packing will be 67%, and the voids which are left are 33%. So we are measuring this angularity number in comparison with the totally round aggregates. If the aggregate which we have is totally round, then the percentage solid volume will be 67% and this angularity number will be 0. So for angular aggregates, this angularity number will increase. The solid volume can be calculated as 100 multiplied by weight of aggregate in a cylinder divided by weight of water in the same cylinder and divided by specific gravity of the aggregate. So you may find a short numerical, 1 mark numerical on this formula. This is angularity number. Let us see specific gravity and water absorption. We know if this is the shape of a aggregate, I am making a rough shape in order to make a differentiation. This is the shape of aggregate. First aggregate is totally dried. Totally dried means these voids has nothing, no water in it. But this aggregate has water filled in this cavity or void. The surface of this aggregate is dry, but the cavity or voids are filled with water. So this aggregate is known as SSD aggregate. Means saturated surface dried. And this is your dry aggregate. So from these two aggregates, we can measure two types of specific gravity. One is your apparent specific gravity, which is calculated by dividing dry mass of aggregate to volume of aggregate without voids. Volume of aggregate without voids mean the volume which is considered is the dry volume. The volume which is considered is dry volume. And next specific gravity is bulk dry specific gravity. This is dry mass of aggregate or this can be calculated by dry mass of aggregate divided by volume of surface saturated aggregate. Of course, this is the value of unit weight. You will multiply this value by or divide this value by unit weight of water, or if you are taking mass, the density of water, here also density of water. So this is it. But what major thing is the volume of aggregate without voids mean this red area is considered for calculation of apparent specific gravity. And for calculation of bulk dry specific gravity, the area which is considered or the volume which is considered includes this blue area also. Means the surface saturated area, surface dried area or the saturated mass of the aggregate is calculated. We have bulk saturated specific gravity. This is saturated weight or SSD weight of SSD Let me write SSD only. You know what is SSD. This is weight of aggregate divided by volume, total volume of aggregate. So this is how we can calculate bulk saturated density. Now in comment box, you will tell me which one of these will be maximum and which one of these will be minimum. Or compare these two. Tell me out of these two, which is more, which comes out to be more for same particle. The next is water absorption. We don't want aggregate to absorb water. So water absorption is also limited to 0.1 to 2%. Aggregate should not absorb water, or we should use aggregate which absorb water less than 2%. Water absorption should be less than 2%. This can be measured by difference in these two masses, or measured by difference of these two masses divided by dry mass of the aggregate. Difference of SSD weight minus difference of dry mass of aggregate divided by dry mass of aggregate. So this is how water absorption can be measured, and this should be less than 2% for the aggregate used in the pavement. The last and the very important property is bitumen adhesion. For flexible pavement, there should be affinity for bitumen in the aggregates. Aggregate should not be bitumen phobic, because if bitumen do not cover the aggregate properly, there will not be proper binding. So for this, stripping value is calculated. What is stripping value? Stripping value is the percentage of the total uncovered surface of aggregate out of total surface area. Total surface area and the uncovered surface. This ratio is calculated in terms of percentage. Now, for calculating this value, the uncovered surface area, a test is done in which the aggregate is fully coated with bitumen and is immersed in water for 24 hours. The temperature of water is maintained to 40 degrees Celsius, and after 24 hours, the surface is observed visually. If the stripping value is more than 5%, the aggregate is discarded. The aggregate is discarded. So these are the tests for aggregates which are required, or these are the properties of the aggregate which are required for better pavement conditions. So for today, this is all. In next lecture, we are going to talk about the bitumen properties. For now, thank you so much.